for this third day, I'm really hoping that some of this feels a little silly to you, especially the starting here of graphing answers. But it's been a long time since you just had to graph your answers on a number line. So I wanted to make sure that we refreshed the whole open dot, closed dot thing and all of that and talked about that. Shifting parabolas, we covered that in first semester. So hopefully as we go through that, you'll go, piece of cake, I already know how to do this. Max and min, we did that as well. Now there are two ways to do it. We could find the maximum or the minimum of a parabola by using algebra to figure out where the vertex is, because that's always the maximum and the minimum. Or we could use a graphing calculator for it. So two ways to go with that one. Then these. This is stuff you haven't seen for a while, because this is the G word, geometry. Perimeter of an arc. You maybe spent, well, gosh, last spring, you might not have even seen this. So, very good thing that we're going to cover that, because it's possible that that was maybe cut in the spring as one of the things that's like, well, we're supposed to just show you the bare minimum, and you maybe didn't even see that. Volume of a box you've seen before, perimeter of a fence you've seen before, and then, unfortunately, somebody at the state they actually had to figure out what was going to go on the MCAs, and they took like 3 years to do this, and they asked every corporate business in Minnesota, what do you want students to know about? And somebody said voting. Now, we as math people say that probably should be in the social studies field. So usually they talk about all the voting stuff in the social studies field. But where do they put it to test you? They put it on the math MCAs. So we're going to cover just one quick thing about majority vote. If there's a question about voting, there probably will just be one. They like to throw one on the test. So example 1 says, graph the answer to 3x plus 5 equals 7. Now, that's a pretty basic problem. We'd say we'd subtract 5 from both sides and divide by 3. But now it says graph the answer. Well, that's because, remember, the MCAs are multiple choice. So you're probably going to look down and see number lines of some sort on there. And then you have to carefully look for where the dot is. We know 2/3 is between 0 and 1, and it should be a little bit closer to the 1 than it is to 0, because as a decimal it's 0.6 repeating. So, right there. And these are the problems that I generally think they're just trying to trick people anyway, because they're hoping that you just look at all the drawings, the first thing you see is 2/3, and you go ahead and mark that one. So just take your time with them. Remember, the MCAs are not timed. Make sure that it's graphed in the correct spot. Because the worst thing you can be when you take a multiple choice test is impulsive. Where you say, oh, there's my 2/3. I'm gonna choose that one right away. Because they're test writers. They know you're going to do that. And so they put 2 problems on there that have the 2/3 clearly marked. One of them is not in the right spot. So just be careful. Alrighty, so this one says, example 2 is graph the answer to negative 4x minus 2 equals negative 22. Help me out. How do we solve it? Add 2 to both sides. Then, so this one again, you just want to slow yourself down a little bit. Take a look at their number lines. Oops, blue isn't working. There it goes. And make sure things are graphed in the right spot. Now, like I said, those feel kind of silly, but they do those. It's just one of the things they want to see. Will you catch it? And then this one says it's changed to an inequality. This one is graph the answer to negative x plus 5 is greater than or equal to 7. So we'd subtract 5 from both sides. And then we'd go ahead and divide by a negative 1. But I think we ran into this yesterday, didn't we? What are they hoping you forget? You have to flip the symbol. And then you're going to look at all the graphs. And this is where you have to think, do I do an open dot? Do I do a closed dot? And remember that when you have the extra equals bar, you have to do a little extra coloring. That's, the inside has to be filled in, so it's a closed dot at -2. And what our inequality says is, all of our answers, because that's what x is, those are our answers, our solutions, are less than or equal to -2. Well, those are going to be to the left on the number line. So again, they're going to put one with a closed dot. They're going to put one with an open dot. They're going to put one that doesn't have the dot in the right spot. You know, those are the typical things that test writers do. Oh, the other thing they'll do on this one is they'll keep the symbol without flipping it, you know, and hope that you miss that as well. Alrighty, this one says graph the answer to 2x minus 3 is less than 11. How do we solve that one? Add 3 to both sides. Then, any flipping for dividing by 2? No flipping. And then you carefully look at what they have. Open or close dot for 7. Yeah, open this time. We don't have the equals bar. And then which way should we shade? Left. Still less than, so numbers to the left will make that happen. So, like I said, it's been a while since you had to do basic number line open close dot stuff. Always good to just take another look at it before you have to take these tests. Now this is what I was talking about when I said we've done all of this shifting of parabolas. But on the ACTs and the MCAs, it might look a little different. They don't have this in that HK format, A, H, and K that we really like. It says, describe how the graph of y equals x squared plus 2x minus 7 can be obtained from the graph of y equals x squared plus 2x minus 1. So this is what I'm supposed to start with. And what I'm supposed to figure out is, what did they do to that to get this one? You notice only one number has changed. So if only one number changed, and this was at -1, and now it's down at -7, what did they add or subtract to that to make it happen? Subtracted 6, right? Because it went from -1 to -7. Now, what does a -6 do at the back of a parabola equation? So this would go down 6 units. So this was translated down 6 units. And you have graphing calculators. So if you look at that and go, I don't remember what we're doing here, you could always graph it, and then you'll see, hey, it's been moved down 6 units. Again, if it's on the MCAs, you have all the time in the world to take the test. But if it's on the ACTs, you do have to worry about, you know, time crunch here. What am I going to be able to do? What am I not going to be able to do if I spend too much time graphing? All right, so why don't you go ahead and do example 6. Again, obtained from means this is where we start. Where did they move that graph? 5 up. Because it went from a negative number to a positive number, we moved that little bugger up. And again, you could graph it if you have time and see, yes, this graph moved up. All right, example 7. Does the graph of y equals x squared minus 4x plus 2 have a maximum or a minimum, and where is it? So we have y equals x squared minus 4x plus 2. Is that an up opening parabola or a down opening parabola? Yeah, because it's a positive x squared. So let's draw that picture. So does that have a highest spot or a lowest spot? A lowest. This definitely has a minimum. Even better, that minimum has a name. It's called the vertex. So 2 things we could do. We could plug it in the calculator, graph it, use Blinky to find that minimum, or maybe, just maybe, somebody remembers the little algebraic formula to find it. Anybody remember how to find the x coordinate? Matt, do you have it? It looks like you're trying to think through it as you're... It isn't. I wish it were. Well, when I put this up here, you remember that little bugger? It's been a long time. X equals negative b over 2a. So we can find it algebraically. We just have to remember to say a is 1, b is negative 4, c is 2. Plug them in here. So the x coordinate of the vertex is 2. Now that we have the x, can anybody tell me how we get the y? Plug it in. Here and here. So 2 squared minus 4 times 2 plus 2. Follow the order of operations. 2 squared is 4 minus 8 plus 2. Oh, I've got too many equals. 4 minus 8 is negative 4, and negative 4 plus 2 is negative 2. So it's at the vertex, 2, negative 2. Now, when we went through this first semester, we said, really, the number we care about is negative 2, because that's supposed to tell us the height, and the height is what we're talking about when we say maximum or minimum. So you might just see negative 2 as the answer. In the past, they have put the ordered pair down. Makes it a little easier to pick out which one is yours. Now, some of you might be saying, Cedarholm, I would have forgotten that formula. I would just punch it in and let Blinky do it. Okay. Well, then let's make sure everybody remembers how to use Blinky. So we have x squared minus 4x plus 2, zoom 6. Blinky's been napping for a few days. We haven't used it. So where do we go? Second trace. And what do we want? We want 3, the minimum. And let Blinky tell you what you have to do. Blinky's saying, are you on the left side of this thing? Well, yes. I'm not very close to the lowest spot, though, so I'll move it a little closer. Enter. Are you on the right side? I am. Enter. I don't want to take a guess. Enter. And you'll notice, hey, that's not a perfect 2, negative 2. Blinky's got 1.9999. Well, it would round to 2. And when we're hitting left bound, right bound, and enter, Blinky is actually doing calculus. So Blinky's not using that little basic formula we use. And Blinky says, this is as close as I can get to 2 for you. So we know it's 2. It's 2, negative 2. All right. Example 8. Does the graph of y equals negative 2x squared plus 2x minus 5, does that have a maximum or a minimum, and where is it? Well, is this up opening or down opening? Yeah, down this time. It has that negative 2 in the front. Max or min? Max, highest point right up there. Raise your hand if you just use your graphing calculator for this one on the MCAs. Okay, because I think some people, you might get a little worried, oh, am I going to remember negative b over 2a? But it's a very small formula, so you might remember it. On the MCAs, it wouldn't hurt to check with your calculator anyway, since you have all that time. So we will have negative 2 over 2 times negative 2, and you could cancel the negative 2's if you want to, but we're going to get a little fraction of 1/2. And then we'll have to plop that back in the formula. Which again, if you don't want to do the fractions in your head, you don't have to. You can punch this in. But following the order of operations, 1/2 times 1/2 would be 1/4. And then negative 2 times 1/4 will be negative 2/4, which is a negative 1/2, plus 1 minus 5. Negative 1/2 plus 1 is 1/2. 1/2 minus 5 is negative 4.5. Or change it to an improper fraction if you want to. 2 times 4 is 8. 8 plus 1 is 9. Like so. Again, you could plug it into your calculator, use Blinky, and find that value as well. So maximums and minimums for parabolas, they're just the vertex. That's all they are. All right, now this part, which yeah, I'm seriously thinking that this would have been something they would have cut in the spring last year for geometry. It says find the length of the arc in the picture below. Well, at the very least, they taught you what an arc was. I know that. This is the arc that they're talking about. So start thinking, well, that arc is a portion of the circumference. I mean, the circumference of a circle is the distance around. And I think, well, I get a formula sheet on the MCAs. Maybe there's something good on here about circles. Here's the area of a circle, pi r squared. Circumference of a circle, pi d. Maybe, hopefully you remembered it's 2 pi r when you use the radius. But you don't want to forget that these formulas are there. They're there for you to use. So if I were supposed to find the whole circle, I could use circumference equals 2 pi r, which means I have to know the radius. Lucky for me, they put it right there. It's 4 inches. So if I wanted the entire circle, the circumference all the way around, that would be 8 pi. But they don't want the entire circle. So now what I have to figure out is what portion of that am I supposed to find? And the answer to that is right here. I'm supposed to figure out this little chunk of the circle. That 70 degrees is called a central angle. So I know I'm supposed to find 70 degrees, but 70 degrees out of what? Exactly. So the portion of the circumference that I want is 70/360ths. Now you could reduce that if you want to, but the answer to this is probably going to be a decimal. So we need 70/360ths of 8 pi. So let's see, I've got my formula sheet in the way. There. .89. Yeah, about 4.89. Inches. So the key to that part is figuring out I don't need the whole circle. What do I need? And they gave us the information of the 70, so we have to use that. And then we just have to remember that every circle has 360 degrees in it, and we'll have what we need. All right. So as I was just blabbing then, I see everybody's working on this one. Go ahead. You do it, I'll do it. Let's see if we all end up with the same answer for this one, finding the length of the arc in the picture below. Got it? 18.33. If it's not working out, let me know. We'll talk through it. Remember, always put those fractions in parentheses, and your calculator will just piece of cake this thing. It'll give it to you very quickly and easily. So, is this intended to be a tough problem on the MCAs, do you suppose? No, but it's just something we have to make sure we've done before we take it so that you don't look at it and go, okay, I've forgotten all about my circles. I just can't help you out here. Here's another one. Not intended to be difficult. Don't forget that there's a formula sheet or a formula tab that you can open up. Find the volume of the box with the given dimensions. So if you did forget the formula, you come in here and, whoops, bring it back to me. There we go. And you could use their generic formulas here, where volume of a box, or volume of actually any shape, is the area of the base. That's why that's a capital B. Area of the base times the height. Now, I wouldn't recommend using that formula unless you have totally forgotten how to find the volume of a box. Because the volume of a box is just length times width times height. Now, can you get there by finding the area of the base times the height? Absolutely you can. You know, you're going to look down here and say, this is a rectangle, so I need 3 times 8. Hey, that's 24. And I have to take that times the height, which is 6. But it'll go much faster if you just remember, hey, volume of a box is length times width times height, and you can get it in there. Now, this takes more work. Surface area. Surface area is, if you were buying really expensive wrapping paper and you wanted to get exactly the right amount of paper to just cover that, how much should you buy? Well, again, without a formula, this one takes a little while, because you could look at the picture and say, well, let's see. The front and the back are going to be the same, so I could figure it out for the front and back and multiply it by 2. The 2 sides are going to be the same. Do the same thing. Top and bottom be the same, and you could work on it that way without knowing a formula. But they give you a formula sheet, which I, of course, have covered up again, for surface area. And again, very generic little formula that says pH plus 2 and then a capital B. So 2 things you have to know. This little p stands for perimeter of the base. This capital B stands for area of the base. So surface area equals pH plus 2b. Oh, where did my notebook go? So like I said, you could just use the picture and say I've got 2 of these fronts, 2 tops and bottoms, and 2 side to side, but it will go faster if you find the formula. So now, perimeter of the base. Peri means around. So 8 plus 3 plus 8 plus 3. So we've got 22 for the perimeter of the base. Times the height. The height of the box here is 6. Plus 2 times the area of the base. That's why it's that capital B. And it's supposed to be a rectangle. It doesn't look like a rectangle right now, but it is. So 8 times 3. 24 would be the area of the base. And then you just grab a calculator and you figure out what you have. And this one, so we've got 132 plus 48. Which is 180 square inches. Now, one of their tricks on these problems is to label it wrong. You know, you look down and you'll see 2 answers that say 180, but one of them will just say inches, and the other one will say square inches. So be careful. Covering it with wrapping paper, that's going to be square units. All right, fencing. How much fencing would you need to enclose a rectangular pasture that is 30 by 60? Fencing. Do you put that in the middle? Well, and we're not talking area. We're just talking perimeter here. And if this is rectangular, well, if this is 30, this is 30. And if this is 60, this is 60. And all we have to do is perimeter, add them all up. Because perimeter is around. 30 plus 60 is 90. We've got that twice. 180 feet. Now, there's probably a formula. Let's double check. Oh, nope. All they did was tell you that lowercase p is perimeter. So they're not going to give you all the perimeter formulas. They're going to say, if you draw it, you can figure out what the perimeter is without us giving you a formula. All right, another fencing problem. A gardener wishes to enclose a garden that is against the side of their home. Oh, now that's going to be different. Because you're not going to need to put fence on the side of your house. Your house is already there. So they wish to enclose a garden that's against the side of their home. They know the side of their house is 20 feet wide. And they would like the garden to be 40 feet long. How much fencing will they need? Well, there's always somebody that forgets that you're not putting fencing over here on the house and gives the entire perimeter. And of course that answer is going to be there because they know we're going to make that common mistake. So right away, write down the 20 feet, the 40 feet, but then cross that one off so you don't accidentally use it. That's where the house was, and the house doesn't need fence. So 40 plus 40 plus 20, 100 feet of fence. Another one that you don't need formulas for. If you just draw a picture, you'll be good. And a voting problem. Always one voting. It is required that a candidate receive a majority of the vote in order to win the election. Which candidate won the election? Okay, so majority. Well, first we'd have to know how many total votes there were. So we'd have to add all these up. So let's do that. We've got 144, 212, 315, and 256. Grand total of odd kind of number there, but it's voting, so 927. Now, usually when you're watching things about the elections, they give you both the votes and the percentage, because, you know, that's usually important information. You want to know what percentage did they get. So the question is, how do you figure out the percentage that they got? How do we do percentage? What you have divided by the total. So Anderson has 144 out of 927. Move your two decimals, so about 15.53%. I'm not going to go back to the main screen right now. I want to punch in the rest of them for you too, especially for the people that don't have their own calculator with them. So there's Eberhard, 22.87%. There's Smith, 27.62%. So let me write those down. 15.53. 22.87. 33.98. And 27.62. So on the news, that's the information that they would give you. Now the question was, it is required that a candidate receive a majority of the vote in order to win the election. Majority of the vote. So out of 100%, how much is a majority? 50 is equal, right? So it has to be more than 50%. So majority has to be greater than 50%. Which candidate won the election? None of them, right? None of them have the majority. So when on earth does this happen? Well, they've taken to some crazy voting styles recently down in the cities, and one of them was a runoff election. And the reason that we say that's kind of crazy is because it actually costs a lot of money. Because what happens is they go through all their election money to get this far, and they find out the top two vote getters, Smith and Thompson, and then they run another election with just Smith and Thompson. And they have to have a majority. The majority of the folks have to vote for them, or they're not going to be elected in. So this is, again, there's lots of new ways that people are doing voting. There was one in the cities that had, in one of the counties, you had to pick your first four choices. So you actually put a 1, 2, 3, and 4 in for the order that you would take them if your favorite person didn't get in. And then they got it down to a spot again where they could have two people that were running for those elections. Again, they're usually really expensive elections, and that's the reason that we don't do that nationwide. But like I said, expect maybe one election problem, you know. They like to throw one of those on there. So that is MCA practice day 3. So what are you going to do tonight? Well, tonight, on Schoology, my computer says I've worked hard enough today. Don't ask me to do any more. Way down here at the bottom. This MCA math tutorial, that's the one that you were supposed to look at before spring break, which I don't think a lot of you did, because when I had to hand out so many note packets yesterday, that was a sign that you didn't do that one. But this is the one for tonight. And this is actually off of the state's website. It's an online version of the practice test for the MCAs. Again, you don't have to go in there and, go through the whole test. Yeah, my computer's got so many windows open right now that it's taken it forever to get there. But get in there and play around so you feel comfortable with it. Part of test anxiety is like, oh my gosh, I've never seen this before. What do I do? And you can get over that. And it explains how the sections work and all that. But you can get over that by just taking a look at how it's going to work. And it will be online again this year. Shouldn't be any paper copies going out to anybody. But it'll just start to feel like you're comfortable with it. You know what the problems are going to look like. You will notice they're all word problems. There isn't going to be a problem on here that says solve 2x plus 3 equals 8. They always find a way to make a word problem out of things. You just need to find the math. Focus on finding the math and how to do it. So, Schoology, bottom of the page, black folder, that'll take you to it. Initially, when I was thinking about, what to do for assignments for the MCA review, I thought, well, I'm going to have people, take a screenshot or something like that. And I thought, you know what? No, I'm just going to trust that, especially the juniors, you have to take this test this year, and you need to get in there and feel a little bit better about it. So that's your only assignment. Get in there, play around with it a little bit, get comfortable with it, and hopefully you'll see